I'm going to explain to you how to find the dual of the given LPP. Now note down that if it is a maximization problem, that means if the objective function is maximized set, then in that case the inequality in the constraint should be less or equal for all before we find the dual of the given LPP. But in this case, what we notice is that the first constraint is already less or equal. The second also it's less equal. But the third and the fifth one, the third and the fifth constraint are not less than or equal. The third one is of equal type, and the last one is of greater or equal type. So for this one, we need to transform it into less or equal by multiplying on both sides by -1. But for this equality sign here, we have converted to less or equal, but we know that this one is equivalent to greater or equal and less or equal. Therefore, we have to convert this third constraint into two in equation. One is less or equal and another one is greater or equal. And then after that, we can again transform that greater or equal to less or equal by multiplying on both sides by -1. By minus sign. So now here let us see, it's given that x2 is unrestricted in sign. Now x2 in unrestricted in sign, that means for x2 you have to replace by x2, replace x2 by x2 prime minus x2 double prime, where x2 prime, x2 double prime are all greater or equal to 0. So therefore the given LPP, or we can write it in this way, note that the third constraint, that is this one, is or can be written as 2x1 plus x2 plus 8x3. One is less or equal to 20 and another one is 2x1 plus x2 plus 8x3 greater or equal to 20. That means first of all you replace this equality sign by the inequality sign less or equal and greater or equal. So therefore this third constraint can be written now as 2x1 plus x2 plus 8x3 less or equal to 20, and this and 2x1 plus x2 plus 8x3 greater or equal to 20. Since it is a maximization problem, so I need to convert this greater or equal to less or equal. So this one can be written as minus 2x1 minus x2 minus 8x3. This is less equal to minus 20. That means you multiply this equation by -1, so that it will become minus 2x1 minus x2 minus 8x3 less equal to minus 20. And then the fourth constraint, that is this one. The fourth constraint can be written as, it is 2x2 plus 8x3 greater or equal to 5. So in this case you replace this one now, multiply by minus sign, then you get minus 2x2 minus 8x3 less or equal to minus 5. Or now it will be minus 2 into what is x2? x2 can be written as x2 prime minus x2 double prime minus 8x3 less or equal to minus 5. Now similarly this one, let me name this as equation 1 and this equation 2. Equation 1 can be written now as 2x1 plus x2 prime minus x2 double prime plus 8x3 less equal to 20, and equation 2 will give you 2x1 minus 2x1 minus, now x2 has to be replaced by x2 prime minus x2 double prime, so it will become minus x2 prime, minus into minus will become plus x2 double prime minus 8x3 less or equal to minus 20. So now the given LPP, therefore the given LPP can be written now maximized set is equal to 6x1 plus 5x2 in the question. But we know that x2 has to be replaced by x2 prime minus x2 double prime. So it will be 5x2 prime minus 5x2 double prime plus 9x3. subject now to the constraint. The first one will remain as it is, 5x1 plus, again here for x2 you replace it by x2 prime, so it will become 5x2 prime minus 5x2 double prime plus 6x3 less or equal to 5. The second constraint is 2x1 plus 7x3. This is less or equal to 10, will remain as it is. Now the third constraint has been converted into two in equation given by this one, 2x1 plus x2 prime minus x2 double prime plus 8x3 less or equal to 20, and another one is minus 2x1 minus x2 prime plus x2 double prime minus 8x3 less or equal to minus 20, and the last one is minus 2x2 prime plus 2x2 double prime minus 8x3 less or equal to minus 5, where x1, x2 prime, x2 double prime, x3 are all greater or equal to 0 now. Therefore, the matrix representation of this one is given by A is equal to, right, the coefficient of x1, x2, x3, and the first one will be the coefficient of x1, so it will become 5, 2, 2 minus 2, again minus 2. Then next, the coefficient of x2 prime, here it is 5, and since x2 prime is absent in this case, so it will be 0. Then x2 prime is 1 here, then minus 1, and then 2. Next, the coefficient of x2 double prime, it is minus 5, then 0, minus 1, 1, then 2, or this one here it is 0, okay, because x1 is absent, it is just x2 prime minus 8x3, so this is 0, and then the last one is x3, it is 6, 7, 8 minus 8, again minus 8 is this one. Now the last row has to be the one that is given by the coefficient of the objective function, so it will be 6 here, 5 the coefficient of x2 prime, it is minus 5, and then 9, and in the last column it should be the value of the equation. So in this case, what is the value in this one? It is 5, 10, 20, minus 20, and minus 5, and here there is no entry here, so you mark it as star marks. So this is the matrix A. So the matrix A can be obtained, the first column will be the coefficient of x1, the first one will be this one from the first equation, and the last row will be this one. It will be 6, 5 minus 5, 9, and in the last column it will be the value of the equation in the constraint, that is 5, 10, 20 minus 20 minus 5. So you are getting this one, but since we didn't have any term in this last entry, so we mark it as star. Then take the transpose of this one. So if you take the transpose of this one, then this will become the first column. So it will be 5, 5 minus 5, 6, 5. This will become the second column. So 2, 0, 0, 7, 10. Then 2, 1 minus 1, 8, 20. And then the fourth column will be this one, minus 2 minus 1, 1, minus 8 minus 20. Next, it is 0, 2, 2 minus 8 minus 5. Then 6, 5, 5 minus 5, 9. Okay, mistake here. The first, this become the first column, this second column, this become the third column, this will become the, I missed this one, minus 2 minus 1. Okay, minus 2 minus 1, 1 minus 8 minus 20. This is the fourth column. The fifth column is this one, 0, 2, 2 minus 8 minus 5. And the last one is this one, 6, 5 minus 5, this is 9 here, this is star. Okay, this star will remain there. So now you see the transpose of this one, that is by interchanging the rows and columns, we are getting the transpose of A as this one. So therefore, this the dual of this given problem now can be written as what now? After getting the transpose of this one, you can write now, therefore, the dual of the given LPP is, this will be the objective function. So in this case, it will be minimize now, minimize, let me take it as W, this is equal to 5, say W1 plus 10W2 plus 20W3 minus 20W4 minus 5W5, this one. Subject to the constraint where the entries in the last row will always represent the coefficient of those, the x1, x2 or w1, w2 of the objective function. Now subject to the constraint, the first constraint is this one. It is 5w1 plus 2w2 plus 2w3 minus 2w4. Since 0 is here, so it will be, there will be no w5. So it is, since it is minimized w, so this will be greater or equal to 6, this one, the value of the equation. The next one will be 5w1 plus, since the coefficient of w2 is absent from here, so the next one will be plus w3 minus w4 plus 2w5. This is greater or equal to 5. The next one will be this. It will be minus 5 w1, then minus w3 plus w4 plus 2w5 greater or equal to minus 5. The next one will be this one, 6w1 plus 7w2 plus 8w3 minus 8w4 minus 8w5 greater or equal to minus 9. Or sorry, here there is no minus sign here, it is plus only. So it is plus 9 greater or equal to 9. And then where w1, w2, w3, w4, w5 are greater or equal to 0. So this will be the dual of the given LPP, that is this one. So before you find the dual of the given problem, see, if the objective function is a maximization problem, always remember that in the constraint, the inequality sign should be less or equal. If some of the constraint, like in this case, it is greater than or equal, therefore in that case you have to convert it first to less or equal, and then if they are equality sign, then for that one also you have to convert it to less or equal, but this one will give you two in equation. One is less or equal and another one is greater or equal. But for that greater or equal, again you multiply by minus 1, so that all the constraint, the inequality in the constraint should be less or equal before we take the matrix of that one. Then after that, take the transpose. The next step, you take the transpose and see what will be the transpose of that matrix A, and after taking that one, then you can find out what will be the dual of the given problem, where this one will give you the first constraint, this will give you the second constraint, the third constraint, the fourth constraint, and the last one actually gives you the objective function. So from maximization to minimization, this is the way. Similarly, in the same way, if it is a minimization problem, then in that case, in the constraint, it should be greater or equal. If there are inequality which are less or equal, then in that case, you have to convert it like what I have done in this case. Now, there it should be greater or equal. So convert first to greater or equal for the minimization problem before you take the matrix A and the transpose of that A, and then from the transpose of a matrix A, you will be able to find out the dual of the given problem. Hope it is clear now how to find the dual of the given problem.